Elementary students solve subtraction problems in many different ways depending on their grade level. Today, I'll show you some of these strategies for solving subtraction problems for grades 2, 3, and 4. Before going over the standard, the strategy, and model, I want to go ahead and talk about the equation or problem that we're working with. We're working with the equation 204 minus 78. Now, for second graders, that could be said in a few different ways, such as what is 78 less than 204? What is 204 take away 78? Or other things like that. Now, the standard that I found for second grade is, I actually found two. So the first one is NC.2.08.1. So just being able to represent and solve addition and subtraction word problems within 100. Specifically one-step problems, two-step problems involving single digits. And then I also thought NC.2.NBT.1, which is understand that the three digits of a three-digit number represent amounts of hundreds, tens, and ones. It's definitely not too early to start talking about place values, so I think this could also be taught at the same time as the first standard that I was speaking about. Second grade students use direct modeling while counting back or counting on to solve subtraction problems, and this is what it looks like. Our problem is 204 minus 78. First, students will crest a continuous number line and place the numbers 78 and 204 on it. Now, I've already had the number line set up, so I'm going to put a dot on 78. And we're going to use the counting on strategy. So we're going to start with the number 78. And then I'm going to put a dot on the number 204 because that is a number that we're going to end with today, considering we are doing a counting on strategy. Next, the student will start at 78, considering we are counting on, and they will notice by benchmarking 10 that 78 plus 2 is 80. Now, I'm using a number line that each tick mark represents 2, so 78 plus 2 is 80, and that's the next tick mark. So in between there would be 79 for reference. Then the student will say, I know that 20 more than 80 is 100 because they're benchmarking 10. The student could also think about it as, I know 10 more than 80 is 90. And I know that 10 more than 90 is 100. So all together, that's plus 20. Then the student will say, I know that 100 plus 100 is 200, and I still need to get above 200. So the student will benchmark 100 at this point, or 50, or just a multiple of 10 in general, until they get to 200. And the student will recognize that 100 plus 100 equals 200. Now, like I said earlier, the student can benchmark 10 or benchmark 50. So 100 plus 50 is 150. And 150 plus 50 is 200. And 50 plus 50 is 100. So that's where the 100 comes from. Now, the student will recognize that they need to get 200 to 204 because 204 is the end point. Now, the student could do this in one way. They could count on using their fingers or their head, and they could say 201, 202, 203, 204. So altogether, it's plus 4. Or the student could already know that 204 minus 200 is 4. So it just depends on that student's headspace at that point in time and their own understanding. Lastly, the student will notice that they have jumped in between as much as they can between 78 and 204, and they know that's the number that they're looking for. So the student is going to add together the amount of places that they jumped. So they can do this in their head, they can write it out, they can use different things such as their fingers or objects, manipulatives, anything to figure this out. So they will benchmark tens and hundreds first. So 20 plus 100 equals 120. Then they will notice that 120 plus 2 equals 122. And then 122 plus 4, which is the last jump, is 126. And they will see that 126 is their number that they're looking for. Now, this is a counting on strategy, like I said, that the students can also use a counting back strategy as well. But this is the counting on strategy. The standard that I found for 3rd grade, I actually found 2 as well. NC.3.NBT.2, which is add and subtract whole numbers up to and including 1,000. So considering we're using 204 minus 78, I felt that this best represented and demonstrated the equation that we're using with this project. And then I also said NC.3.NBT.3, which is use concrete and pictorial models based on place value and the properties of operations to find the product of a 1-digit whole number by a multiple of 10 in the range 10 to 90. So this goes back to benchmarking 10, like we talked about in the 2nd grade strategy. So 3rd grade students will use alternative algorithms to solve subtraction problems, and this is what it looks like. So we have the same problem as before, which is 204 minus 78. So first the student will make the number. So I'm going to put 2 flats down to represent 200. I'm going to color these flats both red. Then I will not put any rods in the tens place because it is a 0. If we go back to the equation, 200, no tens, and then 4 ones. So talking about those 4 ones, we will put 4 little cubes down to represent those 4 ones. Going back to the problem, I know that I have to take 78 from 204, but I don't have enough ones to take away in the ones place. So I only have 4 ones, but I need to take away 8. I physically do not have enough to do that. Therefore, I'm going to have to regroup. If you're going to regroup from the ones place, you would go to the tens. But since we do not have any tens rods, we would go to the flat of 100. So we're going to regroup this flat into 10 tens rods, or 10 groups of 10. I have the number 204, but it's represented in a different way. 100 plus 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 100 plus 100 is 200, and then plus 4 is 204. Now, we're still trying to take 78 away from this 204, but we still don't have enough little cubes to physically take away from our 4 that we have. Therefore, we're going to have to regroup one of our tens rods into 10 little cubes. Now that we have 14 little cubes, we have enough little cubes to take 8 away. So therefore, what we're going to do now is just take 78 from this equation. So we have 204. What we want to get to is take away 78. So this is 10, 20, 30, 40, 50, 60, 70, 1, 2, 3, 4, 5, 6, 7, 8. So we took away 78. So now all we need to do is recount to find our total, considering this is a separate result unknown problem. So what we're going to do is recount. 1 flat, which is 100, plus 2 rods, which is, well, this one's broken apart, but 100 plus 2 rods, which will be 10, 20, so 120, 121, 122, 123, 124, 125, 126. So that means that 204 minus 78 is 126, and that's how 3rd graders would solve this problem using and modeling with base 10 blocks. Standard for fourth graders for this problem would be nc.4.nbt.4, which is another number in operations in base 10. And it says to add and subtract multi-digit whole numbers up to and including 100,000 using the standard algorithm with place value understanding. The important concept here is standard algorithm with place value understanding. In fourth grade, students should be using the standard algorithm to solve problems, but they should still show their understanding using base 10 blocks of place value. Fourth grade students would use the standard algorithm to solve subtraction problems, and this is what it would look like. I'm going to switch back and forth from our equation of the standard algorithm and our base 10 blocks. To create the number 204, so that consists of 2 flats, like we did with third grade, and 4 little cubes. There will not be any rods because there is a 0 if we look at the standard algorithm in the tens place. Back to our standard algorithm, what we're first going to have to do is take 8 away from 4. Now physically, using these base 10 blocks, we cannot do that without having literally nothing left because that would give you a negative number. So physically we can't do that. So what we're going to have to do is regroup. Now, what you would do is you would mark that out, and then you would use the number in the tens place to regroup. But considering we have a 0 there, we're going to have to move to the 100s place. And we're going to have to regroup 1 flat into 10 groups of 10, as so. Only have 1 flat left after we regrouped our other flat, so that's why we have a 1 in the 100 place rather than a 2 now. Now, looking back at our standard algorithm, we still do not have enough 1s to take 8 from 4, so we're going to have to regroup again. Now, since we regrouped, we said that this was 10 groups of 10, and we have this as our tens rod. So that's why I put a 10 there instead of the 0. But since we're still trying to get enough 1s to take 8 away from, we're going to have to regroup the 10s again. So we'll go to our place value blocks, and we'll put this into 10 little cubes. Broke 1 10 rods into 10 little cubes, we have a total of 14 little cubes. Now we can take away 8. So if we go back to our standard algorithm, we're going to write 14 because we have 14 little cubes now, or 14 in the ones place. 14 minus 8 equals 6. Now students can do this in their heads, or they can use their fingers to help them. They can count on, or they can count back. So we're going to go back to here and take 6 away. Now when I said 6 away, I meant 8 away, for a total of 6 in the ones place. Now we would look at the top and we would say 9 minus 7. Now 7, 8, 9. You can count up or you can count down, but the answer will always be 2. So going back to here, we'll take 7 tens rods away from the 9 that we have. Now going back to this, we have 2 tens rods left, so that's why the 2 is in the 10 spot. And then 1 minus 0, you can put a fake 0 there, would be 1. And we still have 1 flat. So recounting and looking at our standard algorithm, the answer, just like the second and third grade strategies, is 126. And if you count it, 100, 10, 20, 120, 1, 2, 3, 4, 5, 6. There's a huge progression from second grade to fourth grade. Second grade being modeling using a number line, third grade being modeling using base 10 blocks, and fourth grade being using the standard algorithm while emphasizing place value at the same exact time.